Hi, everyone. Just want to start, just waiting for a few more minutes to start the session. Uh, First of all, I would like to say hello to everyone and welcome to our today's live session. Thank you all for joining. I'm Amin Tully, and I run this channel, Water Edu Hub. For those who are new here, this channel focuses on practical and technical insights in hydrology and water engineering, from flood modeling and rainfall runoff processes to emerging tools and technologies shaping our industry. To give you a bit of background about myself, I hold bachelor's, master's, and a PhD degrees in civil engineering with a focus on hydrological and hydraulic modeling and forecasting. Over the past 20 years, I have worked at consulting firms, in academia, as well as government agencies across 4 different countries. And happy to be with you guys. Before we get started, just a few housekeeping and engagement notes. This session is being recorded and will be available later on the channel. Feel free to drop your questions in the chat throughout the session. I will compile them and work on them, and we address to all of them at the Q&A session that is happening at the end of this session. If you are joining us from different parts of the world, please let us know in the chat. It's always great to see basically where everyone is tuning in from. And now let's get started. As you know, in modern water engineering, one of the key challenges is fragmentation. Data, models, and asset information often exist in separate platforms or systems. And this generally creates inefficiencies and limits our ability to make informed decisions. Today's session is particularly very exciting, as we will be diving into integrated GIS solutions that can address this challenge by bringing together geospatial data handling, hydraulic modeling, and asset management into a single unified environment. Such a platform can significantly improve decision making and operational efficiency. So let me invite my guest speakers in and introduce them. Hi, guys. Welcome.
Welcome.
Hello.
Thanks for joining. I know that this is early morning for you guys. Thanks for arranging for that. So let me quickly introduce. Basically, this is my pleasure to introduce our guests from BGEO OpenGIS from Spain, who have developed and integrated GIS-based platforms designed specifically for water and wastewater utilities. I start with Xavier Torres. He's a civil engineer with a master's in environmental engineering. He's a partner director at BGEO OpenGIS, and he's the creator and core developer of Giswater, and also a specialist in hydraulic modeling, digital twins solutions, and digital technologies for water utilities. He has over 30 years of experience, and he has worked extensively in hydraulic modeling, water resources management, and infrastructure optimization. And with his past 15 years of experience, he has been focused on developing open source solutions for the water sector. His work basically is driven by a strong belief in making advanced technologies accessible to all utilities, helping improve efficiency and support better data-driven decisions. We also have Namrata Kaki with us. She's a civil engineer specializing in flood risk management, hydraulic modeling, and GIS-based solution. She also joined Erasmus master's degree in flood risk management from 4 European universities. She's currently works as a project manager in hydroinformatics at BGEO, where she contributes to hydraulic modeling for water supply and urban drainage systems, conducts flood risk studies, as well as being involved in international projects using tools for such as Giswater and IberGIS. With experience across Nepal, the Netherlands, South Africa, and Spain, her work focuses on applying open source data-driven approaches to support better decision-making and more resilient water systems. Our session will have 2 parts. First, we will go through the platform, its structure, the key features of it, and finally a few demos of the applications. And finally, we will have the second part as the QA session to address your questions. I will now invite our speakers to walk us through the platform. Thank you, guys. Please, over to you.
Thank you, Emin. Are you listening to me?
Yes.
Okay.
Yep.
Okay. First of all, I would say thank you so much, Emin, for this opportunity to share what we are, who we are, what we are doing, and what is our project. No? And let me show my presentation. Is my presentation online right now?
You can now share your screen.
Yeah.
And I put it up once it is.
Share my screen.
Okay. I have it now.
Yes.
Okay.
Perfect.
So,
perfect. BGEO is a company based in Spain, and what we do is empower water utilities and organizations with smart and cost-effective solutions and services for digital transformation. We do GIS and hydraulic solutions every time based in open source softwares. Right now, we have more than 20 years of experience. We have worked in more than 400 ICT and water successful projects successfully finished. We have been the pleasure to participate in more than 20 research projects with different organizations in Spain, all over Europe, in different programs like European Union programs, Spanish programs, etc. And right now we have more than 100 satisfied customers, not only in Spain or Europe, but also in Latin America and North America. We have developed different projects like Giswater, hydraulics, IMAQUA, and right now we will present you a couple of projects that right now we are very proud to show with you. Our project right now, it has a worldwide impact. In Spain, we are a little company based in Spain. We are only 25 employees. Right now, our projects and our contacts, and we have partners, and we have different projects rising all over the world, like countries like Spain, Portugal, Croatia, Bulgaria, Canada, Costa Rica, Ecuador, Peru, Brazil, and also South Africa, Nepal, or Japan. No, and our maturity degree in any country is different. In our approach to involve our solutions in any country is different. No, but this is what we do right now. Why open source matters? No, why what we do it is important also for you. No, first of all, because there is no license fees. There is no predictable. There is no recurring cost. No, you can know how much is it before to start. Of course, open source not means free software. No, this software has a cost. Has a powerful cost. No, too much developer right now working on that, but it means a very cost-effective solution. With a low price, you will have a very good solution with high quality because of there is no cost to pay license on anything. No, you only need to pay for consultancy services, for training, etc. No, and open source also it's adaptable. No, the workflows can involve your institutional needs. No, you can customize, you can adapt. Because the source code it's available to do this. No, it is transparent. No, there is no vendor lock, and it's full visibility of models. No, it is interoperable, built in open standards and integrates with existing systems. No, it is sustainable. It is a long vision, long-term viability behind a single vendor dependency. No, it has a community behind. No, the communities who drive the continuous improvements through a global collaboration. No? And also one of the key points is that it enables knowledge transfer. No? There is support academic research and institutional adaptation. No? In fact, we not only develop open source solutions, our focus is also to have powerful trainings, to train people and to spread the projects with people that they are interested to work with. In the presentation today, I will explain two of these softwares that we have developed last years. One software is Giswater, the other software is IberGIS. I will tell you a little bit about what is Giswater, what is GIS platform. No? It is a platform, it is a software that integrates asset inventory and hydraulic modeling, both dimensions of any asset in the same environment. No? You can manage in this GIS the inventory properties of an asset, let's say the color, let's say the location, let's say the asset ID, but at the same time, in the same database, in the same software, you will have the hydraulic capabilities of that asset, no? Which means that this is the unique software all over the world that integrates both, and it makes real the possibility to work with an asset inventory and in the same time in hydraulic model. No migrations, no moving data, no nothing. Everything integrated in the same platform. The project was born in Barcelona in 2014, more than 12 years of successful path in a collaboration with BGEO and the Polytechnical University of Catalonia. It was started like a tool to work only with hydraulic models, but the different releases that later on will be done, the focus of the project was changed, and water utilities from Barcelona, they request to make more asset inventory capabilities. For that reason, right now, this software has both dimensions. No, any asset has two phases. No, the hydraulic phase, the hydraulic point of view, which it was created in 2014, and the asset inventory point of view, no, that it was developed later, and it was a requirement from different water utilities that they were interested in this software, but not only for the hydraulic model, no, but also for the asset inventory point of view. For that reason, no, after 12 years, more than four major versions have been released, and lots of civil engineering consultancy firms plus water utilities, they use this software maybe for only hydraulic models, maybe for only asset inventory issues, or the interesting thing here is to work with both in one unique software, no, asset inventory and hydraulic point of view. This is a little bit the architecture of the software. No, this is a database-centric software. Everything is based in a PostgreSQL database. A PostgreSQL database, it is a huge and powerful open source system of databases, and around this database, everything could be connected. No, in fact, data is stored in database, but not only data. There are lots of trigger procedures, lots of logics that also are stored inside. No, this makes simple to connect QGIS to get that data, to edit that data, to modify, to insert, to create. No, and at the same time, through this database, you can easily connect with web devices, mobile devices, SCADA, CMMS systems, including softwares for hydraulic model like EPANET for water supply or SWIM for stormwater management model. Okay, the software, it's able to manage with urban drainage, sewage, and water sewage systems. It is available on desktop, web, and mobile. Furthermore, our Giswater platform is capable of working within integrated hydraulic models, solving Asset management visualization. This is like a current and normal GIS. It provides comprehensive geographical visualization of pipes, valves, hydrants, pumps, storage tanks, meters, and other water distribution assets. It has a predefined, pre-built data model which could be increased, no? Which could be grown by your own characteristics, no? But this predefined, this pre-built data model allows you to work with sophisticated capabilities and rich and complex database issues. On the other hand, you can work with predictive maintenance and asset management. You can identify pipes of assets with risk of failure based on model forecast and historical data. It optimizes the maintenance, planning, and budget allocation. No? In fact, in function of the data, no, we have two core engines to work with rich and good quality data, no? In order to reduce the uncertainties, we work with our model. But on the other hand, if you have poor data, if you don't have quality data, if you only have, let's say, the previous leaks or previous failures that your system has, but you don't have a good quality data about of diameter, about of material, you don't have good quality data about when that pipe was built, and everything, no? And in order to manage a huge level of uncertainties, we work with another model which is based in a Schammer-Howard paper published 50 years before, which only works with leakages. It is the only thing that you need to know when your pipe should be replaced, no? But on the same environment, you can plan and design support, you can evaluate future infrastructures, no? You have specific workspaces to work in the same environment with planned data, no? Without remove and without any interference with the current and inventory data. This makes easy the possibility to planify, to check and to evaluate cost for future developments, etc. And also it is possible to connect this software with maintenance management softwares, no? In order to know how many events any asset have been have been done, how many visits, no, any asset have been visited, and any aspect related to maintenance management that could be useful for you. Here you can see the interface of the desktop GIS. We use QGIS. We have developed a huge plugin, more than 30 buttons, something like this, no? Which makes easy to work with this specific kind of projects, no, based in conduits, pipes, tanks, storage, junctions, blah, blah, blah. And it has lots of functionalities to make as much easier as possible to work with, no? In fact, Namrata will show later on different characteristics about this plugin based in QGIS desktop. This plugin also have specific tools for have stored functions to make spatial analysis, check quality data, run hydraulic models, including you can work by your own new storage procedures, no, by using this toolbox button. In addition, this toolbox button, it has also a reporting button, which it's possible to create your own reports in order to publish and to share with your colleagues in the utility reports like how many kilometers of networks, no, related to your different municipalities, how many kilometers of networks based on your different districts, how many connection services, etc. No? The big thing here is that any process for toolbox and any reporting could be customized and adapted to fit your current needs. Here you can see the asset manage tool, which is amazing tool to determine which pipes should be replaced by doing a multi-criteria analysis. I explained you before with this tool, what we do is to analyze different criteria, let's say diameter, material, age, longevity, number of leaks, probability of failure, and based on these, we do risk theory analysis, classifying what pipes should be replaced and in what order, in what year that pipes should be replaced. This is a water supply asset managed tool, and right now we are starting to work also for do the same for urban drainage and sewer systems. This is a little bit more complicated. We are putting our focus in video inspections, with AI analysis, and this I will say that this will be a new development in next years. The thing is that as this software is database based, it is very easy to integrate with other technologies. It is only a matter to work with different APIs and to integrate, as I said before, SCADA systems, customer systems, mobile and device systems, CMMS softwares, in order to work in a unified and good environment for water utility. Okay, this is a little bit the Giswater platform. Another interesting tool that we have the pleasure to work with is IberGIS. IberGIS, it is open access QGIS plugin, which enables you to work within a couplet model for urban flood analysis, bringing dry-batch networks and surface flows with precision, flexibility, and real-world applicability. This IberGIS, it was released only 4 or 5 months before the first version, and it was done for BGEO in collaboration with a couple of universities in Spain, which they are working with this Iber software. I will explain you a little bit more later, in collaboration also with another companies in Spain. After 3 years of hard work, we released first version 4 months before, and it is a big pleasure because it fills a huge gap to work with these UD flood risk management models. This software, what it does is to try to represent as best as possible the natural processes by doing mathematical formulations and by creating numerical models. It works with Navier-Stokes equations, it works by using the shallow water equations, and finally, you can represent the floods and the velocity, the elevation, the risk in the surface, combining the capacity of the conduits plus the surface of the land. Okay, but before to incorporate the conduits in this project and before to incorporate QGIS interface, Iber, it was born in 2010 by mixing 2 softwares that at that moment there were not exist, that it was Tourbillon and Carpa, and it was developed for these 2 universities in Spain, Universidad de Coruña and the Polytechnical Universitat of Catalunya. And after 15 years, they have released different versions. In 2018, they released the GPU, the Iber GPU, which make faster and faster and faster simulations of shallow water equations. And the key point here, it was in 2023 that it was released, the first version of Iber integrated with stormwater management model. From that moment, it was possible to work with couplet models, drainage hydraulic models, but there were not a good interface. And for that reason, the last 2 years, we spent a lot of time to incorporate this couplet model into a QGIS interface. And right now, what we have, it is a integrated hydraulic and hydrological model, everything in QGIS, by joining both models, the Iber, which is a shallow water equations and hydrological model, and a stormwater management model, which is a hydraulic model for conduits. Both models have been integrated by using the junctions and the gullies, the sinks, as a interconnection points. In the sink, the water from surface could be accessed to the conduits, and by the junctions, through the junctions, the water from the conduits, from the UD system, could be released on the surface. This idea to interchange water from the surface to the conduits and from the conduits to the surface, it is what it makes possible to work with these hydraulic models integrated. This is a free distribution 2D, 1D high resolution dual drainage model software. You can make a download and you can start to work with. And in addition, it is parallelized, which means that works and solves super fast. If you know about these shallow water equations hydraulic models, you need to know that the current condition maybe is your worst limitation. But if you work well with the current condition, the solution of big projects, it is really very, very, very fast. Here you can see different images about the input data, how you need to work with digital terrain models, curve number, land uses. Okay, this is a classical approach of any hydrological model. The thing here is that everything could be done in the QGIS interface. You don't need any software for nothing. You don't need pre-process softwares. You don't need post-process softwares. Everything is integrated into QGIS. Here you can see the different shapes, the different drainage elements that we work. You can see points like manholes, outfalls. You can see lines like collectors, and you can see polygons like roof and ground surfaces. Everything designed to work with 2D and 1D and 2D software. Okay, and you need more special information, attributes, digital terrain models, land users. Everything that you need could be done in QGIS. Here you can see a new image, how it works. In fact, it mixes both models in one single computation, and this is how it works. Here you can see the user interface. Here you can see the toolbar button. It is a matter of maybe 10 buttons in QGIS, and here also Namrata will show you a little demo how it works later on. Here you can see the results. This is a image of a profile. And here you can see the results. This is an image of the elevations and the depth and the velocities that we have in the surface. And here you can see depth and velocities, but in this case not for surface, but for conduits. And including we have done several proof of concepts, and it is very easy to publish these works in a web. In BGEO, we are a GIS company, and we love to use QGIS web platform, which is the the QGIS desktop, but on web-based, no? And we have done different proof of concepts, and the future is to go in this direction, not to use QGIS web in order to make able these hydraulic models, not only in desktop environment, but also in web environments, no? By doing the same, but working in a collaborative model and doing amazing things, everything in web-based solutions. And that's all. You can find us in the plugin Giswater in the URL giswater.org. You can find the user's manual, the GitHub, everything there. And also for IberGIS, you can find it in the Iber Aula URL.
Thanks, Xavier, for your great overview of the packages. So before we move on to the demo section, I would like to have a reminder to everyone. Feel free to drop your question in the chat, and we will definitely address them at the end during the QA session. So now over to you, Namrata, to walk us through the applications to see how this interesting platform works. Please.
Yes, thank you. Let me just share my screen. Okay. Can you see the screen? Is it now okay?
It says, let's move to the live demo. Am I right?
No, it's the
Okay.
other one.
The other one. Okay.
I think this is mine. One moment.
Yep.
Yes.
It's okay. No worries. I'm just switched
Okay.
to the other one.
No
Please
problem.
go ahead.
Okay. Yeah, this is just a video that Chavi showed before. I saw the animation didn't quite work, but here you can see how the results in the web would look like. So it's basically the results of your simulations, whether it be velocity or depth. So you can publish your flood risk maps or anything out of your simulations results. First of all, I would like to thank Amin for giving this opportunity for us
My pleasure.
to
Thanks for joining.
present IberGIS. So in this session, I would be focusing mostly on IberGIS. So now you've heard so much about IberGIS, how to download it. So it's pretty simple. You just go to the website iberaula.es. And then here you find a lot of things about Eber. You do not necessarily have to install Eber separately when you need just the plugin itself. You can go to the website a little bit down, and here you see IberGIS button, and then you just have to click on it. And there are a few more clicks, and then you can see general information about the IberGIS, and then here you can see the latest version for QGIS. Currently, it only works in Windows. Eber, however, it can work in Linux, but for IberGIS, it is only possible to work with Windows at the moment. So here you have the information of this QGIS plugin, a little bit of images and pre-processing descriptions, the mesh generators, basic general information about the plugin. You can also have documentations here. It is just a startup of how to start. It's both in Spanish and in English. So if there's any Spanish speakers, it would be really helpful for them too. And there are like in English as well. So you just need to click here. The only thing here is you just need to register with your email ID, but that's all. It does not ask you anything else. And as soon as you log in, you can download the zip file, and then you install the plugin with the zip file. So once you have the zip file, it's pretty simple. It's a basic QGIS. You just go to the plugins, manage and install plugins. And then once you have it, you can install from zip. For the moment, I already have it installed, so I will not install it again, but just wanted to show you the basic procedures of how to obtain the plugin. So once we have this one, you can see this button. This is the IberGIS button. You also have here the open user folder, the actions. You can also open the plugin folder to check what it is there. All the Eber executable are already there, so you do not have to install it. It's just a backend. It works on the backend when you execute simulations. To start on, you just click on the button, and then here you have a pop-up dialog. You can say a name for the GeoPackage. So as you saw in the presentation, IberGIS work with GeoPackages, and then it goes back and forth with the simulations and Eber. We are currently working on PostgreSQL too, so having database is even faster than GeoPackages, and multiple people can work at the same time in the project, which is a really, really good advantages for really big projects, and multiple people collaborating with it. But for the moment, we only have GeoPackages for the release. So you can decide any name, let's say a demo, and I can give a description demo, and I can give the path to anywhere. I will make a new folder in my desktop and then select the folder. We do have an example project that is in a hypothetical area, not hypothetical area, sorry, hypothetical network in a part of Spain. So if you just like click here and the English language and example data and accept, the GeoPackages will be created. So it's just few seconds or yes, basically few seconds of processing, and then your GeoPackages will be created. Usually what happens, yes, as I said, few seconds. So the project is created, and now you would like to have the QGIS project as well. So for that, the GeoPackages already is taken, the GIS file, you can name it, and the GIS folder, and then once you accept, you can open the GIS project. So this is the first overview, as you see, once you create the example project in QGIS. It's a hypothetical network near the San Boi de Llobregat. It's I don't know if there are many football fanatics, but it's close to the area of Camp Nou. This is Camp Nou of Barcelona. So this is, however, I have to say this network do not by any chance reflect the real scenario of the networks. It's just a hypothetical network to give an example and let the user work and figure out what the plugin is capable of. So once you have this, it's a couple of buttons as you see here, not this one, but this one. So you have, as Chubby mentioned, we have 10 buttons. So there are like two different tabs. One is mostly related to preparing your input data, then other is related to making a simulations. For the input data, as you can see, we have different layers as well. So you have 3 groups. In those groups, you have SWIM, which is the stormwater management model, where you have your INP file, junction, divider, outfalls, all those necessary elements for your drainage networks, you can have it. And then for Eber, it's mostly for the hydrological part, which is the inlets, the hydrographs, the boundary conditions, the bridges, the culverts. The P inlets are basically the inlets in the surface, which is like a drainage to the network. The land uses categories, because you can have many land uses cover as it works with curve numbers, and you have the mesh group. So for the swim, you can either draw the network, but of course, if you have a big network, it's not so practical. So how you can do is you can import INP files. So if you have any INP file that works with any hydraulic model, you can just import it, and then you have everything set up in the layers itself. If you have Giswater, which we said before, it's a hydraulic modeling tool too, you can have the INP file from that Giswater too. So you can basically connect both plugins. As we said, it's totally integrated, and we can use it both ways. You can have the INP file and then integrate here as well. Then next, what you need is, for the Eber, you need the land uses. The most important part, I would say, is the roof and the ground, of course. The roofs are basically the buildings, as you can see, and the grounds, that represents the ground, of course. And then for the boundary conditions, you can decide where are your inlets or where are your outlets. It's just you can have multiple boundary conditions, as this is the beauty of having QGIS and having the possibility to work with multiple boundary scenarios. You can create as many boundary condition scenarios as you like, and then just choose one which you want to work with the mesh. And you can have like any boundary conditions saved to the mesh once you have created the mesh. Of course, here we don't have any mesh. We will create it in a moment, but just wanted to say you can create, duplicate, edit, anything you want to possibly do it. And then to create a boundary conditions, it's pretty simple. You just like go to one of the edge that you want to create a boundary conditions. You click here, and this line is selected as a boundary conditions, and then you can decide if it's an inlet or if it's an outlet, if you want to have like total discharge or what elevations for an inlet, critical or subcritical. If you have time series for that inlet, you can also add that one. So yeah, it's pretty simple, one click, easier, faster, very, very user friendly, as I must say. To have the time series, now how you would say like how to input this time series, we have this button called non-visual objects manager. So it's basically these non-visual objects, which are curves, patterns, time series that are necessary for your stormwater management model, but also for your IberGIS model for the time series. So you can have for the pumps, you can have like curve patterns like this. Sorry, yes, like this. For the flow, for your storage, you can have a pattern. So those kind of thing you can have. You can also have the patterns for the flows, the daily, hourly, anything that you like. So everything is quite integrated what swim needs for the input to run a simulation. And for the time series, you can have rainfall or inflow. As I said, in the boundary conditions too, you can create an inflow. So if I just push this create button, then here you can see like BC elevation, which is boundary condition elevation, BC flow is boundary condition flow, inflow hydrograph, orifice, rainfall, temperature, anything that you possibly need for your modeling inputs, you can put it. Not just that, you can have relative or absolute, or you can also include a file. If you have raster folders for rainfall, which is quite common these days, you can also input your rasters for the rainfall. So you can choose if it's an intensity or volume. The only catch here is the rasters need to be in the same folder as the geo package for now, for this release. But rather, except that, everything works perfectly fine. And then you can have controls as we have in the stormwater management model. Then we have this another button, which is add bridge, or you can edit a bridge. For example, let me just add a dem, so it's more easier. So once you have this plugin, you can open the plugin folder, and in the resources folder you can have these example files where you can have the geo package, INP, the raster. So for example, if I have this dem raster here and I want to create a bridge, for example, here's a bridge. Let's say if I add a bridge, of course that was not so great, but yes, I can add a raster file, which is my dem, and then add my bridge according to that. Of course, my dem is super high than the bridge, the top elevations. This is the default ones, but of course you can change it. Let's say 45, and then let's say 44. So one of the ideal bridge that you can create. Not just that, you can also create some piers in between. So let's say I have a pier at 15 meters, then another one, then another one I have at 16 meters, and then I have opening percentage as 100. So you can also create a bridge, like a pier. This opening valve is just like a percentage of opening of the bridge. So if you have any obstruction, you can also decrease those, and that will be integrated and the modeling too. Um, so yes, you can do as you like. And the same way you can also edit the bridge. So if I had saved the bridge, then I would be able to edit the same way. After that, what you need is, of course, a hydrograph. So you can just make your hydrograph any point. So we just have this point. You just create a hydrograph. If you look into the attribute table, so it just like has the time series, as I mentioned you before from the dialog box. You can put any time series that you like, and you can just click what you want to put it. Everything is interconnected and like made it easier for you to work with. So hopefully it's much user friendly as we assumed. The same way you can also put a culvert, not just the bridge. For the culvert you just need the opening, the start elevation, the end elevations, the manning, those kind of things. And the next is, let's talk about the mesh. So for the mesh, we have two important layers, as I mentioned before, the ground and the roof. If you open the attribute tables, then we have the ground, the code, which is just the code of any features. Then you have the land use. For you can have multiple land uses as you like. For the moment, for the example, we just have open spaces. You can have custom roughness and curve number, so you can have multiple values of curve number of roughness according to the space that you are working with. So it can be variable, but also you can also have raster file to get those values too. I will show that you in a moment. One of the thing here you have to be careful on with the cell size. So higher the cell size is lower the resolutions, of course. So if you want higher resolutions mesh, then you can of course decrease down your cell size. And the same with the roof. The roof we have a little bit different. We have the slope, the width, the roughness, if it's connected to the network or not, which outlet code it is, which outlet of the network is connected to, the outlet volume, if it's going to the street, if there's any infiltration volume. So all of those things. If it's like a green roof, then you can have the infiltration volume and the cell size in the same way. So you can have all those set it up as per your data. And then once you have that, you just need to have the work with this mesh manager button. So this mesh manager button, as same as boundary conditions, you can create multiple mesh. So you can change your roughness or change your curve numbers, land use values, or change the how it looks like. You can create multiple mesh for your project. So if I just create here, you have these couple of input data checks. It just checks if they're all the layers of all the polygons of grounds and roofs align well with each others, if the vertices are okay, those kind of things. We also have a couple of tools in the processing toolbox that helps you to make it fit as possible your data or the layers. And then once you have it, you can create the mesh. You can also apply the boundary conditions, that is the current scenario. So you can have multiple boundary conditions and you can just choose one, which one is your current scenario, and you can say, okay, apply the boundary conditions from the start. Then you can choose the elevation. So as I said, we have the DEM. You can also choose a raster for the roughness. So just to have for the example, as I said in the example folder of the QGIS IberGIS plugin, you have these rasters, roughness and curve numbers, so you can import those and use those. If you have your native one, you can of course use those. You can also use from the ground layer itself, from the attribute table, and the same with for the losses. And then you can just give a name as you like, and then you create a mesh, and it's pretty fast, and it's saved to the geo packages as well. So if you like the mesh, you can keep it. If not, you can just modify it. Not sorry sorry, not just that, you can just select some features. If you just want to like create a mesh of one part of your area, then you can also do that. So there's a lot of possibility you can do. Not just that, you can import a mesh if you have already. You can also export it as 2DM, which allows with working with QGIS native mesh one, and you can visualize in 3D as well. So those kind of thing. You can also have it as raster. If you are expert in eber, so you can also export it as eber format that works with eber. And if you don't like it, you just delete it, saving space. And then what next? So you have the mesh, you have your roughness, you have a land use. I just want to show you a couple of processing toolbox. So in the processing toolbox of QGIS, we have these two groups, subgroups, IberGIS and IberGIS mesh. As I said before, everything has been made so that it's user friendly as possible. It's helping you to integrate all your data as easy as possible. So we have all these import gram geometries. So if you already have some shape files or anything, so you can just import those. Import inlet geometries, which basically means the inlets that takes the 2D flow to the network, like this. The the roof geometries, of course. There are certain checks to be done before, as I said, to create a mesh so that your mesh is created correctly. So you also have this processing toolbox to check close vertices. If you have like really, really close vertices, if you have intersecting or overlapping polygons or so on, you can have mesh validations, and you can just like choose a ground layer, choose a roof layer. Not just that, you can choose any layer from your QGIS, and after it's okay, you can import them into ground layer. And if you have any null geometries, roof null geometries, all those things, you can just like run and it does the check, and then it says like, okay, right now we don't have any errors, but if you do have any errors, then it creates a temporary layers that shows where exactly the error is, which is really helpful if you have really big area and if you want to correct those. Then the other thing is you might have to connect where your outlets go to the network, or where your roofs go to the network, the water. So you can also have these set outlets for roofs. So if you just click on your roof layer, and then you have the raster layer, and then the outlets are of course the junction, then you can just like run, and then automatically it gives you at least the basic idea of how the water is flowing. You can also change it if you like. It's just a matter of changing, sorry, here it's just a matter of changing the code. So if you have the code, if you know that certain junction is taking water from certain roof for sure, then you can also change it. But for the preliminary analysis, I think this works pretty good. The same with the inlets to outlets too. So now we have the layers configured, the mesh, the connectivity of the roofs and everything. So what next? Of course, we make a simulation. And for that, we already have a hydrograph. We already have a rainfall installed here, sorry, integrated here. A quick mentioning for the mesh, that if you have any like certain point of depressions or certain areas that you want to do change your mesh with, but it's not actually present in your DEM at the moment, or like in the layers at the moment, you can use this mesh anchor lines and mesh anchor points. So they are basically 3D lines and 3D points, which has these elevations, and if you just like create a line with native tool of QGIS, and then you have the cell size, you can have the Z values in the vertices, and it will generate the mesh as per this one. So you can alternate your mesh that way too. Okay, so for simulations, the important thing is you have to set up the options and your simulations necessities. So this is the button where you have the go to Eber options. So these dialog is basically made for you to check your settings for the simulations. The swim options is, of course, that is needed for your stormwater management model. So it basically reflects whatever you need for stormwater management model. If you have used swim, then this is exactly the replica of what you have. You can have anything set up, the date, the um, yes, basically everything for hydraulic modeling. For the swim results, yes, you can do anything that you like. You can also have like for certain subcatchments, but for the swim, we don't need for the subcatchments because it's the whole connectivity of the 2D flow and the 1D flow. For the Eber options, we have also quite a few of buttons. You can choose for example, here for precipitations, you can choose like no rain if you just want to work with the dry water flows. But if you are integrating 1D, 2D, then of course we can have a rain, hydrograph. You can also have a raster. As I mentioned before, we can also work with the raster. For the moment, if I just choose hydrograph, then it's going to work with hydrograph. The current limitation, however, we have for IberGIS is it only works with the curve number method. However, soon this might be fixed too. And then we have the option to just say, okay, there are no losses. You can have time interval. You will see in a moment. And for the results, you can choose if you want depth, velocity, specific discharge, water elevations, the maximums of depths, velocities, all those things. You can also choose how like how defined your raster results will be. So you can put the cell size 3 or 2 or like 1 even for your thing. You can also have these raster result frames so that you don't have to have like big raster for the whole area if you just want to like have a certain area to, noticed. Then you can decide if you want to work with complete network or only inlets. The only inlets, it just works with the 2D flow and it does not couple with the network. This is quite handy if you just want to see how your hydrological data is working with. But once you have your network configured, you can work with the network flow too. And then we have the check project tool, which basically checks everything that you have, like the data, the values, the layers, have everything intact, all the necessary data. In case of certain data, for example, connecting with roofs with the outlet, if it's not there, then by default the Eber takes it the nearest element. So that can also be done. But certain things like having the manning out of range or things like that, it will definitely check it out. So once you have it, I'm not sure if I accepted. Yes, no. So once you check everything, you just need to accept. Sorry. Just to mention again, you also have this raster options, which basically is like a post-processing of your results. That is symbology for your depth or velocities or any water elevations. You can decide what range you want to, like from the beginning. If you just want it like that, of course, you can change it in the layer itself. But if you have like certain fix already, you can just set it up there and then it can work with it. So once you have that, everything is ready. This is also the check project. As I said, it just like checks anything. If I do something, it just checks multiple checks and it says like, okay, no items duplicated. So it also checks your swim network, but also like the hydrological parameters. So once you have this is quite general button, play button for simulations, I would say. You just click on the execute button. Here also you have the option to go to the option again and see if everything is okay, and if not, you can just like change it and accept it. Then you can just select a mesh. So as I said, the beauty of having multiple mesh and multiple boundary conditions is you can have as many mesh as you like with multiple boundary condition scenarios, and you can choose which to select. And then you can just give a folder. Here I can just say, okay, it's the simulation first, of course, because it's not always the first simulations that works in hydrological. If it works, then you are probably doing something really, really wrong or really, really right. So
Fully agree. That's a good point.
So, so yes, once you select a folder, you just have to click on OK. And then here you can see, okay, it's exporting config files. So what it is trying to do is it's trying to write all the input for files necessary. Oops, sorry. Usually this does not happen. It's the Murphy law. um, but luckily I have another that is already ready. So once you have the simulations, what it tries to do is it tries to um, write all the input files for the stormwater management model and also for the IberGIS, and it tries to like make a simulations. So after that, you have the simulations. You have these raster files. So you have all these results for the depth, the velocity, and if you click on the temporal layer, you can see how the water is evolving and connected with the nodes. So of course, this is small tiny areas with not much less of like previous or different infiltrations values. So it looks pretty much the same. But if we take a look at the velocity, you can see how the water has been evolving in your network. So you can see how the water is going. Of course, to check your 2D flow, it's also necessary to analyze your 1D. So not just the 2D one, you can see how your flow in the pipes is working. So I just this one, and it says load vector results. So the vector results are the 1D results. So if you see here, if I do it from the start, and then if you notice here, these are the node flooding points. And of course, the water that comes first with the higher velocities are from this point. So if you just see here, so here you see the water is coming here. And at the end, there is water going to the outlet because of course this is an outlet. So water is moving towards it. So not just the 2D part, you can also check your 1D flows. You can make a profile. You can just click on any 2 points here, initial node and the final node, and you can say with water, and you can have the period for the timestamp that you simulated. And if you draw a profile, then you have this dialog box, and then you can just play and see how the water is going in your network too. Other than that, it's basically whatever you get in your swim network results. So if I just tick at everything, I can see these conduit searches. So if I try to, for example, label it with maximum, like, yes, or our lim ups or inflow, then you see, okay, this is the flow. And also for the arc flows, you have in the attribute table all these maximum velocities, the flow, the depth, at which time. So it's basically the replica of what you get for the stormwater management models, the results. So yes, and I think that's basically it. For the nodes, it's the same. You can have all these values. So all the results that you get from stormwater management model, you can have it here. You can also have the report summary. So if somebody has used stormwater management model to swim, you can have many results. So those are the reports that you can get from this one. So as you can see, everything is done in QGIS. You didn't even have to like go back and forth, open a different software to get your results and then come back. With parallelized GPU capability of IberGIS, it is much faster. And I have to say, we have been working in real projects and with mesh more than 1 millions, and like for 3 hours of simulations, it's just a matter of like half an hour or so, including the exporting the results. So this is how easier it gets from the pre-processing to the post-processing, I would say, because that is the hardest part every time running a simulations. Running a simulation is just a button and you just configure it and that's done. But the most challenging factor is how do you integrate those results into nice maps? Like if you have risk maps, it's always nice to have clearly visually expressive maps or like the results that you have, uh, whether it be communicating to the public or whether it be publishing your research papers. So those kind of things are really really necessary, and I think with IberGIS it's really really user friendly and helpful for people to work on. And I guess that's all from my side.
Thanks. Thank you very much. Thanks for your insightful presentation. I think we can now move to the QA session. I have got a couple of questions. Interestingly, some questions actually came to me through LinkedIn. I don't know why. Perhaps
Okay.
people have been shy, not putting it here. But anyway, it's good to have some interesting questions. So perhaps one by one, I go through. I start with a general one that I think it's good to summarize basically. So it asks for, I think it's from Ivy asking, can we summarize the key features of the platform that you have? If you want to highlight, like one of the key features that you want to tell us, as the ultimate ones. Yeah, please go ahead.
Sure,
Key,
you
key
are.
features. Key features. I should say that for both, for Giswater or for IberGIS, open source, no cost of license, collaborative projects, you can work with both in a cloud environment. You can deal big projects by working with different civil engineers on the same time at the same project, which is unique on the world, and everything integrated into QGIS desktop or QGIS web. This could be key features: open source, collaborative projects, and QGIS front end.
Perfect. I think that's definitely very important because we all know how tedious is just like moving around the files from QGIS to, let's say, hydrological models or hydraulic models. Yeah, definitely that's a very important one.
And for big projects, the engineering workflows are in serial. This engineer do this. After that, here you have the files. You take the files, you work with files, sharing the files, and it is impossible to deal with big projects in a short time. We are talking about we are rewriting the workflows of the engineering processes. We can work with as much engineers as possible in a cloud environment working with the same database. In fact, this is not my dreaming, it's real. We are working, for instance, in a big project in Costa Rica, the whole country of Costa Rica, they are working with Giswater. They have different and several engineers all over Costa Rica, or in Brazil, in the state of Goiás, they have different engineers working with hydraulic models with the same layer. Everything connected, and you can build very big projects with this technology. The key point is not open source. It is impossible to do with current technologies,
Exactly.
And with our technologies, it is possible to work with.
Great. I think that brings me to the next question, because if I remember correctly, Namrata, you mentioned that we can have it as a web-based system. We don't need to install anything. So the question is, do we need to have like certain capabilities on our laptop or PC in order to have like handling GIS and the modeling tools at the same time? Do you have any comment on it?
The key point here, it is not your computer, it is a matter of your skills. It is not easy because you need to know a lot about informatics, you need to know a lot about hydraulics, you need to know about databases and about QGIS, And in spite it is everything open source, you need to spend too much time for yourself to learn and to grow in this area. For that reason, we can provide everything built for you, if you like, in a cloud environment.
Okay. So it's cloud-based, basically.
It's up to you. We provide cloud-based solutions, but you can download and you can deploy by yourself.
That's right.
But we always say that it's cheaper for you if we help you.
Yep, definitely. Yep.
But it's
Thanks.
possible to do. It's possible. In fact, let me say that it is not only possible. We had a very nice no even when 5 or 6 years before, some people from Portugal they contact us saying, "Thank you for Giswater. Congratulations for Giswater. We have deployed it in our system, in our utility, and we had an award for the Portuguese Water Utilities Association as the best innovation tool of the year." No, okay, you can do.
Yeah, that's great. That's great. Yeah, I have another interesting question. I think we know that some government bodies perhaps have some data privacy constraints. So the question says that from a data privacy perspective, does the platform collect and store the user's input data? Any comment on it?
You can deploy your system where you want. If you are looking for Australian data centers, you can deploy everything in Australia data centers. No, this is not ArcGIS that they have based in Oregon or they have it in California data centers. No, and your data it is stored in another country. In our case, we provide SaaS solution, but we can deploy a SaaS in Australia, or you can deploy your own. No, in the case of water utilities that they are working with Giswater, they have very concern with this issue. And let me say that more than 90 or 95 utilities that we are working with, they have their own data in their own centers, data centers, no, in their own headquarters, no. But this is a decision with this software, which is open source. You can decide what you want, no.
So it's up to the user basically how to.
Anyway, about the technology, this year we will have the ISO 27001, which means the cybersecurity and data policy ISO. We are working to make our solutions as more confident and as more safety as possible in terms of data. But let me say that data, it is always a matter of human behavior to protect data. You can have the best solution and with all the compliance, but it is a matter of your people to keep your data.
That's right. I fully agree with that. Yeah, great. So let's move to the next one. I think this is a comment or maybe a question saying that talking about the Giswater and IberGIS, it is quite interesting if these both tools can be integrated with each other. Any plan for that?
I can answer that. Wait, I can show you quick. We didn't have chance to show you what Giswater is and what Giswater is capable of. So if you can share my screen, yes. So this is like how Giswater looks like. As I said, it's just a hypothetical network for an example, and it has a lot of buttons. It might seem overwhelming at the time, but I would say like every button is like really, really useful for your data management, network management. So you have this network everything. As we talked about, Giswater is dual database model. So you have this inventory side that is all stored in your database, and then you have this hydraulic modeling. So with all this hydraulic modeling configured, you just have to have these both plugin installed in QGIS. And once you have your geo packages, I say the land use part, at least the hydrological part, if you have set it up in your geo package, then you just can import your the geo package project as we loaded before. And then once you have it, we have this button called go to EPA and go to Iber. Go to EPA is simply like having a simulations for stormwater management model. So again, as I say, you do not have to like get out of QGIS. You can run the simulations in backend, the stormwater management model, but also like you can have go to Eber, and it's simple as we saw before. Like it's similar. You have the stream options, the Eber options, and you can just run the simulations. So it's really, really interesting how if your network is all configured in Giswater, you can just have a geo package and then connect with IberGIS.
Perfect.
In fact, both plugins recognize each other if they are installed and they work together.
Exactly.
They work
Great.
together.
Yeah. Thanks. This is quite interesting. And then I have another question. Perhaps now that we are talking about GIS system, the question says that is it possible to install the HEC GeoRAS as a plugin in QGIS, similar to what is available in ArcGIS? Honestly, I'm not GIS expert. Any comment on that?
I don't know.
Yep.
I don't know.
I think this is more technical. I would say, saying that it's more like in the
we
software
don't use,
development.
We don't use ArcGIS. We don't use HEC-RAS. We use it HEC-RAS, and we know HEC-RAS, but we are not users because we use Iber. And it's impossible to answer this question. No, we don't know if there exists some plugin like this in the QGIS environment. Maybe something should exist, no? Because the QGIS environment, it is amazing, no? And there are hundreds and hundreds of nice plugins. Maybe Namrata is looking for something, no? Because we don't know. I don't know, at least.
Yeah. And I think just I add something interesting, that in Australia, one of the famous hydraulic models that we use a lot in industry is TwoFlow. Yeah. And that's a plugin in QGIS. So for us, I think, in Australia, I think that will be very comfortable to basically switch to these type of platforms, because both QGIS and TwoFlow are very compatible, and they are in use actually here. Okay, great. Perhaps my next question will be around the loss models. I think, Namrata, you talked about, I think you said that only curve number at the moment is there. In Australia, we are using the initial loss and continuing loss models. Let's say if any industry is interested to adopt your platform, is it possible to somehow implement any kind of loss or even routing requirement that is common in Australia into that system? If yes, how hard it is? Is it like very challenging work for you guys, or easy to implement?
It is. Maybe I should answer this. First of all, we are not the core developers of IberSoftware. IberSoftware has lots of hydrological different models. IberSoftware has green up, modified green up, curve number, modified curve number. No, it has a lot. And when we decide what hydrological model to incorporate as first inside this QGIS version of Iber, we decide curve number because it's something the most universal one. But I should say that if the model is implemented in Iber, I should check, because I don't know if the model that you are talking about, it is not implemented. It will be easy. If not, it will be a little bit more complicated, because first of all, we need to implement that model in Iber, and after that, but let me say that Iber has lots of hydrological models. It is widely used for different universities, including now we decide that in QGIS, in this IberGIS, to put visible the curve number model, but it is possible to activate green up modified and curve number modified, because academical issues, the universities, they had interested to train and learn people in these more academical hydrological models, not that curve number, no? But we should check this. If you text us about this specific hydrological model, we can answer you with more accuracy. We're talking with the universities. They are the developers of the Iber software and the hydrological model. Here, BGEO, we are the QGIS developers. We only put this amazing software on the back in a QGIS interface. No?
Perfect. Great. I think my next question will be around 1D, 2D hydraulic modeling. Uh, uh, can you have a bit of like explanation about that? Is it easy to handle also on this platform, about the boundary conditions and other things in the hydraulic modeling? Maybe just share a bit of your thoughts and experience on that, please.
Yes. So of course, I mean, with this is the coupled model is actually a PhD of one of the creators of Eber, which is Esteban, and he has pretty much validated this model like top notch. And when you do the simulations, it's pretty, if your input data are correct, it's pretty much validated in that case. Within the boundary conditions, as you say, with the QGIS, I think it's much easier to have your simulations and like check your as I said, the main advantage or the main beauty of like having QGIS plugin is to ease this post processing feature, and with this you can actually see if your data actually aligns or your results actually aligns with the real case scenarios. If there is a depression where it's not ever gonna happen, then of course you would know as a modeler. I would say in that sense, it's easier. I also see another questions. Maybe I can just answer in that case. It's if
Yes,
it's
please.
user friendly or not.
Yep.
I would say yes. Of course, it's made to make it user friendly. I would say as much as possible. We have tried to create as much as processing algorithms to ease your data input processing, but also like for the post processing of the results that you get. So 100% I would say user friendly. Having said that, of course, you would have to have basic QGIS or GIS knowledge. Of course, how to change the layer symbology or how to input a layer or those things like that. Of course, you would need to have it. Maybe not like super coding or having high SQLs or stuff, but definitely basic knowledge you would definitely need.
Yeah, thanks. Perfect. I think another question that I've got is related to the asset management part. I think one of the interesting features that you highlighted in your presentation is that we can just simply change the assets, let's say upsize a culvert, or I don't know, change the size of a pipe, straight away run the model. So can you elaborate a bit more? Because that's, I think, something interesting, because most of the utilities throughout time may need to make some changes or upgrade assets. So I think that will be something very interesting for utilities to have everything ready. And yeah, I think it's a good point. Please elaborate a bit on that.
Yes, I can explain this one. So what we have in Giswater is with this asset manage plugin, you have this multi-criteria. We could not show everything here, but we do have a YouTube video if anybody is interested to go check out our YouTube video. But yes, basically in the asset manage plugin, we have this multi-criteria where you have these pressure flows from the hydraulic modelings. You have these diameters, you have the materials, the longevity of your pipes. You also have these the leakage, as I said before, you can assign to a buffer. Of course, usually when somebody goes to the field, they say, oh, there's probably a leak here, but they do not know which pipe is exactly leaking. So you also have this assignation of the breakage or leaks to those pipes. And once you have all this configured, you have this multi-criteria analysis, and it calculates within your budget and within the time frame that which pipes need to be replaced by the years. So of course you cannot replace everything, which is not going to be economical for you or for your pocket, but of course with this tool you can have this criteria analysis and prioritize. You can plan it strategically which pipe needs to be replaced first, and to see that okay, this pipe is to be replaced, and if you want to check it with different diameters, if it actually fits your hydraulic capacity, then with Giswater you have this feature called plan sectors. As Chubby mentioned, with Giswater you can have planning and maintenance and those things. You can create a new network without having to touch your original network, so without having to modify your network. So it just creates like a substitute over your original network, but your original network is not changed at all. And then you can just run a hydraulic model through that. And through that, you can see, okay, if it's actually working or not.
Perfect. Thank you. I think another interesting question that we have got, I think you mentioned that briefly, maybe it needs a bit of elaboration. Can this system integrate with existing asset management databases or SCADA systems, for example? Let's say they have some systems available. Is it possible to integrate it? Yeah, please.
Yes, of course. In fact, one of the biggest efforts that the development team have been working on last year, it is in the Giswater API. Right now, with that API, you have different endpoints to connect Giswater with every interesting software in the utility. Let's say leak detection software, let's say SCADA software, let's say CMMS software, no? Let's say customer software. No? There are methods to interoperate in a standard way of APIs with JSON methods, no? With endpoints, very well documented and very easy to interconnect. And in the end, we are working with hundreds and hundreds of water utilities, and everybody's looking for the same. Everybody's looking for connect a couple of data sets of customers, 5 or 7 different families of SCADA systems, and everything is the same, no? And the Giswater platform has this amazing API right now that it makes easy to interoperate with another softwares.
Thank you. Yeah, perfect. That's interesting. I have one question. It's actually my question I want to ask is that I know that basically by right, since we have the GIS, QGIS as the core of GIS pod, so I assume that, let's say, the hydraulic model outputs will be the typical output files like TIFF file or other files. So if, let's say, in the future we want to incorporate digital twins into the system and have the outputs being connected, how would be that condition? I mean, have you thought, because I saw that, Javier, you're doing some digital twins work as well.
Yeah.
So may I know whether this has been done in kind of connection between the tools? That would be nice to hear about it.
This is the next generation Giswater platform. We are working hard in it, no? When the utility has a good inventory data, when the utility has a good hydraulic models data, when the utility has the facility to has the tools and to has the environment to create new hydraulic model as you want, because everything is integrated, no? Updated hydraulic model based on your current network, based on your last improvements in your network, no? When you have this capability and you have calibrated models and everything this is provided by Giswater, it is very easy to take that hydraulic model, let's say an EMP file of a suite of APANET, putting that EMP file, that calibrated EMP file in a black box, no? And running that EMP file in that black box in a continuous mode, each 5 minutes, no? Triggering with forecasted demands, triggering with forecasted rainfalls, no? Triggering with anything it's interesting for you, and providing information to the utility manager with SMS, mail, whatever, no, WhatsApp, no, about the results of that triggered forecasted things, and to deploy an environment for that manager, an easy, very basic environment to run what-if scenarios. Okay, I will have a problem in that tank because tomorrow I will not have water to serve. Okay, what if I close that valve? What if I open that pump? It's easy. Simple things. They are not hydraulic modelers. They are operators. They need a simple tool, only with one button to click, right button, open valve, close pump, and that's all. This is what they need. And we're working on that. And the biggest point here is that you can have good hydraulic models updated because you have Giswater. And for that reason, no, you can have a very good EMP files, and with that EMP files, you can work in your twin. And when that EMP file does not represent your current network because your current network having changed, you can get from Giswater, and you can generate another one in an easy way, because your hydraulic model in Giswater is continuous updated. Because what is the tool? You are making an asset inventory tool, a new word. No, okay, we have deployed in this rod, we have deployed 10 conduits more. Okay, you draw that 10 conduits, and automatically that 10 conduits, they have a hydraulic model. And for that reason, no, you can work with that hydraulic model, you can calibrate it, and you put that calibrated model in your twin. And that's all. This is the idea. No, it's the easiest part. The only thing here is that the tool should be simple and basic, because the end user, it is not a hydraulic modeler. The end user, it is an operations manager, no? And they need simple things and basic things. And it is what we are working right now.
That's perfect. That's interesting to hear. I think I know that all around the world, lots of efforts are now have been focused on this topic, and perhaps that will be the future of our industry, not only in perhaps this area, maybe other areas as well, like wastewater management, as well as water supply and so on. Yeah, that's very good. Thanks for explanation. We have got a couple of more questions here. Someone asking, what are the computational requirements for running 1D 2D simulations on large urban networks on this platform? Is there any specific requirements? I remember you mentioned that basically maybe not. Maybe you want to add something?
Yes, well, I mean, the better the computer you have, of course, the faster the simulations is gonna be. But having said that, you can also work in a normal laptop. Like, for example, I have a laptop that has GPU, and it's not much like high, like supercomputers. It's just like 16 GB RAM. So I think that works pretty good for me too. So if you have GPU, that's even better, because with the parallelized version, it works faster, the simulations. If you don't have GPU, then of course it will go to the traditional one, and it might take a little longer for your simulations to work on.
Perfect, thanks. And we have another question. I'm not sure whether it's related to your work, but anyway, I will ask it. How can we link up the Geo AI for better research direction? Any idea about that?
This is good, very good question. No, people used to ask about this topic in last month, and okay, we didn't have chance to check Geo AI. What I should say is that it seems amazing. No, in our network there are some people that they are doing amazing proof of concepts, and I will suggest that it is a very powerful issue, but we don't have chance to integrate and to test it. It is in our future developments, no, to integrate not only GeoAI but also any kind of agents, AI, to make easier the things for the end users. But right now we don't have any experience, no, more than proof of concepts that we did, and it seems amazing.
Great, thanks. And perhaps related to this question is the fact that nowadays we are getting access to more data, like the real-time data by sensors or other means of data collection. So do we have also in the future the capabilities of connecting that live stream of data, let's say rainfall or water level, other things, to this platform and incorporate it into the modeling? Any comment on that?
Yes, of course. We love open source solutions. We love to work with the standards, with OGC standards, Open Geospatial Consortium. And of course, our recommendation here is clear. please use the OGC standard sensor things, which is the standard and official interoperability of IoT. No, there are lots of standards. In fact, Siemens has a standard, any company has a standard, but exists an OGC standard, which is the Open Geospatial Consortium, and this is sensor things. And you can deploy an open source data server called Frost server, which is for free. You can deploy it, and this Frost server, it is the middleware, the perfect middleware to get data from MQTT systems, from any device, to store that data and to publish that data in a standard mode, which means that automatically you can see it in QGIS, because QGIS has a data provider of sensor things, okay, and as well desktop or as well web. And this is our big recommendation. Please, if you are talking about GIS and hydraulic model, use the OGC standard, which is called sensor things, of course, for IoT. Is what we use.
Yeah, that's a good.
You don't need to develop nothing. You have the plugins in QGIS to see that data. No, it's perfect.
Right. That's right. Yeah, I think I can see that nowadays. Yeah, there are lots of demand for that, especially for both asset management and, of course, forecasting when it comes to, let's say, flood or leakages in the systems like water supply or wastewater systems. So nowadays, yeah, there are lots of demands for the live streaming of data, which is quite interesting. And I believe, yeah, that will be also another area for lots of future developments very soon. Great. I think, being conscious of time, I have one more question perhaps to ask. It's a general one, asking, how does the platform ensure data accuracy, consistency between GIS hydraulic model? Any comment on that?
Yes, I can answer that. So we have this check projects button, as I showed in IberGIS, and the same with Giswater too, which basically checks if your topology is correct, if any necessary inputs for hydrological modeling is filled out or not. So yeah, I think that way you can ensure your data is accurate, but also like consistent throughout your network.
I think right now more than 150 checks have been done when you click the button, in order to guarantee the consistency of the data, not only for hydraulic processes, but also for inventory processes. If you have a date for the build date of some asset, and you have a date for the end date of that asset, because that asset was built in 1960, and that asset, it was deprecated at 2010, the build date should be before that the end date. And this sounds crazy, but people make mistakes, and sometimes they put the date of the end before the date of the start. And this is a simple example of the hundreds of checks that Giswater does in order to guarantee a good data consistency for you, not only for asset inventory, but also for hydraulic model, of course.
Thanks a lot. I think, being conscious of time, I want to also have reserve some time for closing remarks. So, guys, do you have any final remarks? What's next for our audience? If you have any comments or having anything to highlight, please go ahead.
Yes, of course. First of all, you can please make a download of Giswater. Take Patient to work with, enjoy a lot. And of course, our business model is to spread our work all over the world. In Spain, we're a little company, I said that we are not involved in 10 or 12 countries, with partners doing different things, but looking for interesting people and interested people to work together, and we open our hands to find people also in Australia, to work with the research project with universities like we did in Spain or Europe, to work in some pilots, to work in anything that people could be interested to work together. We will appreciate a lot, because it's our core, it is to work in a collaborative way and to find people and partners all over the world.
Thanks a lot. Yeah, and I think it would be great maybe, Namra, to put also a link in the chat box in case if anyone wants to just give it a try now, maybe click on it. I've got one more question. Since we have like few minutes time, let's talk about that as well. The question says, how long does it typically take for a utility to implement this platform into their existing workflow or platform that they have? I think it depends on the size, I guess. But yeah, please, you are the experts. Share your thoughts about that.
Yeah. Okay. In terms of technological issues, migrate data, it is fast. To create the interoperability with the SCADA, no, CRM, CMMS, etc., could have 4 or 5 months. And the worst thing here is to teach the people to work with, no? And this process could be overwhelming, and we have to find a step-by-step process, teaching people slowly, no, in order to make the compatibility with the current system meanwhile they are teaching in the new system. And at the end, for small utilities, 4, 5, 6 months. For big utilities, 10, 12 months. This is a real time to deploy with success the new system, no?
Great, thanks. And one more question also I personally have is, if let's say a utility wants to work with your system, generally they may be interested to also store data under a platform, like a backup storage. Let's say, I'm just giving an example, let's say Google Drive or something similar, the cloud-based storages like OneDrive and other stuff. So how does it work? Is it going to be like simple, you can connect it, or you have like a special preference there? Any comment on that?
The thing is that the core engine, no, the core engine of the data in the case of Giswater is a PostgreSQL system. It's a database, no. What you can do is to create a daily backup and putting that daily backup, whatever, no. But we are not talking about files. We are talking about service, no. And we work where customers like. If customers like to work in Amazon Workspace or to work in Google Workspace or to work with Microsoft, Azure, it is possible. If not, you can deploy your own data center, or you can use another data center, another clouds that they are not the biggest one, no, but anything is possible, of course.
Okay, got it. Thanks a lot. I think we have covered all the questions. Thank you guys for joining and your insightful presentation, and also the comments and your answers to the question. Thank you very much. I also would like to thank our audience for participating. It was a very good and interactive session. So this session, I believe, highlighted the value of integrating GIS, hydraulic modeling, and asset management tools into a single platform. We saw how beneficial it could be, and something that I believe is demanding very increasingly in water utilities specifically. So if you found this session useful, the recording will be available on the channel to watch if you want to review the demos later. Feel free to share it with your colleagues and friends. And also, please don't forget to subscribe to the channel for more content like this on hydrology and water engineering. Thank you very much. Thank you again, and see you in the future sessions. Have a good evening.
Thank you.
Thank you.
Have a good evening.
Thank you, guys.
Bye.